points are written to a second data file. Manipulation of the recorded data files will produce the desired straightness information. From the earlier discussion, the signal voltage in the first setup represents the sum of protrusive straight edge error and positive z-direction carriage error. Therefore, straight edge protrusions and positive z-direction carriage errors both equate to an increase in signal voltage. The signal voltage in the second setup represents the difference between protrusive straight edge error and positive z-direction carriage error. Straight edge protrusions still equate to an increase in signal voltage, but now positive z-direction carriage errors equate to a decrease in signal voltage. Subtracting the second data file from the first data file and dividing the result by 2 will yield the straightness error in the carriage. However, before a meaningful plot can be obtained, the signal voltages must be converted to displacements and the slope in the data must be removed. The conversion factor here is 2.5 micrometers per volt. Various routines are available for slope removal. A least squares fit is used here. Remember the sign convention. An increase in signal voltage represents an increase in the positive z-direction and carriage error. Adding the 2 data files and dividing the result by 2 will yield the straightness error in the straight edge. Again, the voltages are converted to displacements and a least squares fit is used to remove the slope in the data. The sign convention here dictates that an increase in signal voltage represents a protrusive error in the straight edge. This is but one measurement of the X-slide straightness. The repeatabilities of the errors is still unknown. Once repeatability limits have been established, an error budget could begin to be constructed. After measuring the other errors, a tolerance could be calculated for how precisely a workpiece could be fabricated using this machine. A well-constructed error budget could even form the foundation on which various error correction schemes could be implemented. Each student will receive 2 data files representing the straightness data for some straight edge and carriage combination. Included with the files will be information describing the measurement parameters. The homework assignment for this lab has 4 parts. First, manipulate the data, either manually or computationally, to obtain straight edge and carriage straightness graphs. Next, identify sources of measurement error. Comment on the significance of the test conditions, that is, the speed of the carriage, the sampling and averaging parameters, etc. Finally, recommend further tests to better characterize the straightness of the straight edge and carriage. The lab write-up should follow the standard format consisting of the introduction, procedure, results, and conclusion. The write-ups must be typewritten or legibly handwritten. These write-ups are due at the beginning of the next lab.